Okay, guys. Can you see my screen? Can you confirm it in the chat window, please? Am I audible, loud and clear? You can able to see the lectures, the presentation slides and everything. Okay, cool, cool. Thank you so much, Gopal. Thank you, Greta. So, till now, what we have learned and what is the agenda for today's session? Let's discuss. Okay. Till yesterday, what we have seen is like what is before that. Let quickly give an introduction to the course for any new joinees. Uh, Myself, Vijay Sharma. I'm a Google certified professional cloud architect and principal SRE and lead DevOps engineer. So for a top four MNC company. So, welcome to this GCP training by Logics Lab Technologies. We are a premier institute providing services, IT related training and professional services to different students and organizations. This session is going to start at 7 a.m. Indian Standard Time every day, and this is the course fee. And for any queries, you have to connect with these numbers and also join the WhatsApp group for all the communications. Let me put this in the chat so that you can join. If anybody missed joining the WhatsApp group, uh, please join so that you will be intimated about the course updates, any new notifications, any general thing. So we cannot contact you directly and send you, right? Look, this is one channel wherein from the institute side, whichever the notifications are there, we will share with you. And also, if you face any issues such as like recordings or needed class notes or anything, just please try to contact the support numbers here, and they will be available from 9 a.m. to 7 a.m. IST. So, as per the policy of the institute, the first five sessions will be free to attend, and sixth session onwards. The Zoom meeting link will be provided to only the registered participants. And these are our different social media platform links. You can please go through them and have a look at it, and please provide a nice review if you like our courses and the way we are delivering the services. So where are we? Okay, we are in module one, and in the module one, what have we completed? We have completed the basics of cloud computing, and now we are going to see what are different cloud service models, what are cloud deployment models, and we'll start with Google Cloud Global Infrastructure, and we'll have a Google Console overview. And if time allows, we will look at the other aspects. Otherwise, we'll start with the further topics, and we'll conclude module one by tomorrow, and we will have a lab demonstration and guidance tomorrow. So let me quickly go to today's slides. So yesterday we had a look at different cloud service models. Okay, like infrastructure as service, and platform as a service, and software as a service, like that. So let me give an example. Okay, we understand better if we share example, right? So let me start with that. One second. Okay, there seems to be a glitch. One second. Okay. Uh, Let me start from here. Okay, fine. Yeah, as we have discussed, cloud service models are the way with which the public cloud provider or private cloud provider provide their services. When this is service, right, it is consumed by the end user, that is we and the organizations. So in the way with which we consume it and the manner in which we consume it determines what type of service it is and what type of offering it is. So let's say an example, like you all might have had chance to, eat a dish called pasta, right? Or you can have you can have a beverage called coffee or something like that. Any eatable or something like that. Let's say you want to have pasta. Did anybody had pasta in their life before? Put it in the chat, okay? If anybody didn't even had never ever in their life had pasta, then also put it in the chat. Just quickly put it in the chat in 1 minute. You I want responses from you. You had it right. Thanks, Sai. Uh, and others had pasta, just put it in the chat. Okay. I want you to be interactive just because it is early in the morning in India and also evening. It's evening in the US and other time zones. So I want everybody to be interactive and so that you will be learning better. Okay. When you type and you engage, you learn better. You understand better and remember better. So coming to pasta, right? Like how many ways we can make pasta? I want to consume pasta, or you want to consume pasta. So let's say if somebody in a remote forest want to make pasta, what they have to do? Okay, they have to first grow the flour. I mean, like the wheat or rice, and then make it into flour, and then make it into dough, and then they will need to create the sauce, and then need to make it. Similarly, if you want to make coffee in remote areas, what you need to do, you need to, if it is a tea, you need to grow the tea plant, and fresh leaves you need to pluck, and then you need to boil and do that. Or you need to grow coffee beans and then roast them and brew them and this thing. But is that the way we do every day? No, right? We don't do it. What we do, we go and buy prepackaged ingredients from Walmart or any superstore, more or somewhere. We go, we buy the prepackaged ingredients, like packed pasta and packed sauce. And what we do, we bring that to home and cook at home. Okay. Now even then, like you have to buy pasta and make by yourself. What if I don't know that? Okay, I don't know how much water I have to add, how much time I have to saute it. Let's say I don't know that. There is another way also, right? You have Swiggy, Zomato, you have online ordering food, right? Then you can simply take your phone, you can order, right? Or you can take out, you can drive by, pick up the take out, and you can come, right? So that's one way. Okay, but still when you come back, right, like you have to reheat it, or you need to at least you need to sit somewhere, right, in your home or somewhere. You need to make sure you will have the necessary utensils for serving it and other things. Now, the last one, what if you don't want any fuss about it? You just want to have pasta. Don't need to worry about anything. How to cook it and whether it is hot or not. Where do I sit? Then what you need to do, you just go to a restaurant and just order pasta and they'll serve it. And you need not bother about the utensils, you need not bother about the ratio of water to, you know, the flame and pasta, and then how to cook it. So now I want to understand this and translate this into how we do it for cloud computing. Okay, let's start comparison. Now, I in the initial in the first example, what did I say? If you're in a remote place and there is no availability of ready services, you have to grow your own, ingredients, or you need to prepare your own ingredients. It's like your on-premises data center, guys. Okay, you need to buy your servers. You need to set up the rack servers. You need to set up the disaster redundancy setup, DR setup, backup or failover setup, and then you need to provide the cooling for those servers. You need to have the necessary experts or engineers for managing the data center for that. So who can afford that? Can a startup afford it, guys? Can a startup afford it? No, right? Like uh, for startups, they want to quickly bring the product to the market. And also nowadays, every team, every company is looking at like how we can be the first to market. In that sense, the data center model doesn't work. Okay, I'll tell you when it works. Okay, but the data center model is very slow, very rigid. It is inflexible. We cannot scale it. Whenever the demand is there, you cannot scale it, or you want a different type of service. And whether if you are let's say you want a GPU based service, you want to utilize it. Let's say TensorFlow you need to run, or something like machine learning algorithms you need to run, but your servers are based not on GPU, then it won't work. You need to bring a new server. So how much cost, time, and energy has to be invested again into the process? So that model was the classic data center model, and now we are in cloud model. In cloud model, what did the second example I say? You go, you buy the prepacked ingredients. Okay, what you need to do is you need to cook it. Okay, you need to do it. Similarly, the cloud provider will offer you hardware, storage, or networking. But it is up to you how you design it and set it up. For example, I want a VM with certain specifications and a certain OS on it. So now what I would do, I would go to Google Cloud Console. I will look for compute engine, and I will look for which category of compute engine which suit my needs, and I will take that SKU. SKU means standard keeping unit. That is the category. Okay, it is like telling how much RAM, how much vCPUs or cores of CPU is available, like that. Okay, I pick it up. I will determine whether I'll determine whether I'm gonna use which OS. I'm going to go with uh, Windows operating system, or Linux operating system, or anything else. Okay, so we have to determine how the everything. Only thing, the responsibility of the client provider is make sure that hardware is fault tolerant. That means if any of the underlying hardware, like maybe the chipset malfunctions, or maybe the necessary the underlying hardware doesn't function properly, or if it is a networking thing, whether if the routing policy or something which has to properly work for SDN, if some bug is there, if it is not working, something like that. So the responsibility of underlying hardware. No, Sai. GCP is a cloud provider, and GCP provides all the services. I'll come to that. GCP is an umbrella term for all the. It's a cloud provider providing all of these services. Which service is which? We will come to in a minute. Okay. So now, buying pre-packed ingredients, like providing a hardware to you, is called infrastructure as service. Now, what is the example of that? I have mentioned one here already, the compute engine. Okay. Similarly, you can ask for storage. Okay. What type of storage? You can have something called a block storage. What you put in that block storage is up to you. Again, I'm giving raw examples. Okay. The relevant service, will come to that. The another example we have taken is, you don't need to cook it, but you can order it online and take it out and you can eat it. Okay, this is kind of thing where a platform is provided to you. Okay, a platform is provided to you, but you need to bring your applications and bring your code. You need to configure that platform according to your needs and make use of it. Okay, for example, I will provide you a VM with OS and database like MongoDB installed over it. I'll provide that service to you. What you need to do, you need to configure the tables and the data, necessary data you need to fill in and make use of it, something like that. Okay, or if I want to use containerized applications, I can go to some platform called Google Kubernetes Engine, where they will provide you necessary control plane and the worker nodes. I'll come to you in the necessary model. You don't need to confuse about these things. In the respective modules, we will cover at in depth about what GK is and other things. But for our example, I'll simply put it. Okay, Google Computing GKE, or Google Kubernetes Engine, is a platform where you can pack your applications as containers and you can deploy them or sort of install them, or you run them on that platform according to your needs. And you need to tell uh, why it is a platform, not as infrastructure, because underlying infra has OS on it, necessary patching and everything is the responsibility of the provider, that is Google's. Okay, what you need to be careful is whether your applications are secure or not, whether you are configuring it and taking care of the scaling and other properties or not. That is your responsibility. And finally, I can give you a call, I can reserve my table and I can go have it, and I can come back. As simple as that. That's called software as a solution. That means I I don't need all this first, okay? I just need to use the service. Whatever you underlying technology you use, it doesn't matter to me. Can you think of any example? Okay, anybody put it in the chat. Anybody think about an example where you don't need to think about anything underlying. You just need to use the software. That's it. Super Sai. Yeah, I'm 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 thankful to everyone who is put it in the chat. Thank you guys. Thank you. So basically, Gmail or Google Drive or Salesforce. Salesforce need it's a SaaS come pass. It's a link, Saujanya. We are not going to discuss more about why it is a mixture of both. But yes, certain part of it, yes, it is a SaaS. So SaaS or software as a service, essentially what it does is that you don't need to bother about underlying technology. Like if you want to upload a file to Google Drive, okay, you don't need to bother about whether the underlying storage is a 100 GB or 1 TB or 10 TB. Or if you are going to copy 100 files, whether there is space left in the underlying storage or yeah, of course, in your account there should be some quota left. For example, I'm a premium Google Drive user. I would have 100 GB quota, 200 GB quota. Okay, if the quota is there, till that quota, it's the responsibility of the Google or the cloud provider to make sure that the allocated hardware or storage or networking is available to you. So now I have given you certain famous or most used services. There are also certain things like function as a service, container as a service. We will quickly go to that and quickly. Okay, this is a SaaS, PaaS, and infrastructure as service. So whatever the responsibility of the user is in the rectangular box, and the responsibility of the cloud provider is mentioned here. Okay, this is the responsibility of the cloud provider, and this is the responsibility of the user. That is, we are the organization. Similarly, for PaaS, we need to have the environment decided. We need to decide which runtime environment. Runtime environment means whether we are using Node.js or .NET or Python. What is the technology which our code is going to run? Okay, that is runtime. And development tools, if we are using anything, that is our decision. And finally, when it comes to SaaS, whether we are using mobile device or web-based application, as simple as that. The rest of the thing is the headache of the cloud provider. Okay, let me see if any chat is there. Okay, Gmail. Okay, okay, nice, good. Now let's proceed with the few things which I have mentioned, that FAAS and CAAS, that is container as service and function as service. Now, function as a service is a subset of software as a service. Okay, or you can think it as you have certain Python code or application code. Now you don't need to run on like how to build it and do it and run it or compile it. Okay, if you have a Java code, you don't need to worry about whether I have to which underlying tool I have to use, like Eclipse or something. No, you don't need to worry about that. You just need to bring your code, the application code, and deploy it and set the necessary parameters, like your environment variables or app settings or data and configurations you need to provide. That is function as a service. When to use this, when to use each of this, I'll tell you. And I'll discuss container as a service, and then we'll discuss container as a service. Will have containers provided to you. Container means, again, I have given an example, right? You have certain application code in with you. Now when you want to run that application, right, you, if you package that, just the code necessary for the application to run, and along with that certain libraries and certain files which are necessary for communicating with the underlying OS. Underlying OS could be anything. It could be Windows, or it could be Linux, or anything. But in a VM versus container, the difference is that in a VM you have underlying hardware only. You have to select the type of OS or operating system. But in a container as service, right, you don't need to bother about that. You just need to package your application and run it as a container, so that it is lightweight, can boot quickly within seconds, fraction of seconds, and it can scale as per the demand, and it will utilize the computing or the infrastructure very efficiently. So we will discuss at length about containers as a service in the Kubernetes module. But for now, for our purpose of discussion, we will think of containers as a packaged small bits of application. Okay, an application fully packaged, but it is very lightweight, so that it can be quickly deployed and quickly boot up, and it can be quickly scaled also. Okay, now when to use which part of it? Okay, now I have a restriction for my organization. Like, you are in China, okay? Chinese government is very strict about the content and the data loss and all. So in such scenarios, you might be having access to public, or you might not have, or certain part of your users data is not allowed to be saved in public cloud or shared infrastructure. Let's say you are in a financial organization, and certain part of the transactional data or certain data is, as per policy, you are not allowed to share it with anyone, even it for saving it, okay, in and used in a using in a cloud provider. So in that case, we will use traditional on premises. Now, in infrastructure as service, when do we use it? We need control, but we don't want to take the responsibility of how many servers I have to procure, and how to which virtualization hypervisor I have to use. You don't need to worry, but I need control over which operating system I have to run, what type of runtime I have to install, whether Java 11 or Java 17. I need to control whether it's a Python. I need to control how to. So if you want control over your, about your application and how you run it, take infrastructure as service. When to use platform as a service? Now you are a entry cloud engineer, and you don't have expertise about the underlying hardware, and you don't want even to bother about the runtime. I just want to do the scaling and the necessary configuration, like developer. Okay, I don't want to bother about like how to patch an OS, or how to make sure that necessary processes are running properly or not. I don't want to bother. So in that case, you take platform as a service, but you need to again take care of the scaling part. That means, if an application demand grows, how does it scale? Okay, how much I'm prepared to pay for the scaling, and then data and configurations. Then comes to software as a service. You don't even need to worry about the underlying code also. You just need to make sure that the necessary settings are in place, and you have the certain quota to use it. That's it. So function as a service is when you have the code ready with you, and you just need to quickly test it and run it for development purpose. And containers as a service is you have microservices ready with you, and you have to quickly deploy them and make a POC out of it, or proof of concept, or certain startup is there, and you don't want to work with Kubernetes engine and the complexity associated with it. You can use it. So is it clear, guys? Are you clear about this thing? The examples for each of these. Let me quickly go through that. Okay. Now, when to use PaaS and when to use SaaS. Okay. When you want control over your offerings or the application you want to run. The level of control determines the what type of service you use. And if you want, if you don't want to take much of the responsibility, you won't even have control over it. So it's a trade-off. Okay, the more control you are asking for, the more responsibility you have to take. Okay, so in PaaS, the responsibility is with the users or the developers are responsible for developing and deploying and managing their applications. Okay, what does the Google do? The cloud provider do? They will provide the underlying infrastructure and also the hardware, virtualized hardware, and the basic OS, and what else? Networking and storage. They will provide, and you are responsible for developing the necessary functionality of the application and deploying that and managing. And the managing means scaling and other things. In SaaS, however, Google Cloud is responsible for managing the software also, okay, including the development, deployment, updates, and everything. You are just responsible for the data. Data is the new oil, so data is important, and the settings and application, and the terms of service and other things. So examples for PaaS: the App Engine, Kubernetes Engine, Cloud Run. App Engine is nothing but you will get certain amount of like compute and memory, and you don't need to bother up the type of VM or underlying everything. Okay, you just need to tell like how to scale, but it is more or less like a VM, and a very small scale, and you can select it on the fly. So similarly, Cloud Run will enable you in building your applications faster. And Kubernetes Engine, as I have mentioned, these are basically containerized applications. If you have to run it, you need to run on Kubernetes Engine. Okay. Similarly, SaaS, uh, the example is Gmail, Google Workspace, Google Calendar Drive. All these are SaaS. Okay. So when to use PaaS, when to use SaaS, the choice or the decision based on certain questions. You need to ask when, what, where, why, how. These questions you need to ask. Like for example, if you need a custom application and they are a ready to use software solution, if you want the first one, you go for PaaS, and if you want to ready use software solution, you go for SaaS. And the technical expertise, if you have, you can go for PaaS or IaaS. Whereas if you can develop your own application, you can go for SaaS. Okay. If you don't have your own expertise, then you can go for SaaS. Then how much control need? Okay, depends on that. You can choose, and what is your budget ultimately. Okay, so these are the questions you ask when you need to go for choosing the services. So these are the service models. If you want to define the service models, basically infrastructure is as service. Basically means like the capabilities provided to the consumer, that is you. What is the capability? Like you will be able to use the processing power, that means CPU, storage, the memory, and the networking infrastructure, and other fundamental computing resource, so that you can start and able to deploy and run your software. Google doesn't bother about what runtime, what software you are going to use. It only provides the raw processing and storage and network, and it is up to you, like Google Compute Engine. Similarly, this is an example, like diagrammatic one. Similarly, what is PaaS? In the PaaS, what is provided to you is like more than hardware, that is more than infrastructure as service. Another layer such as operating system and runtime in some cases is also provided to you. So your application can be built using any programming language of your choice, and tools are provided by the provider. You just need to use them and develop them and configure that application, so that you can suit you can customize the application according to your needs. Similarly, the example is, again, I have said, right, App Engine, Google Kubernetes Engine. These are examples of platform as service. Then finally, software as service, where you will be provide not only the platform, hardware, and runtime and scaling everything. You just need to just configure and set the data. Okay, that's it. You just use the software, Google Workspaces and Google Docs, Google Cloud, Google Drive, and everything. Till here, anything, any doubt, any Saujanya, you got the examples you have requested for yesterday. Have you guys clear? If you are clear about the concept of service models, please put it in the chat. Yes, so that we'll move on. Okay. Thank you, everyone. Thank you, super guys. You are fantastic. Okay. Next one is deployment model. Okay, deployment means in installing or copying or setting the code or configuring the code in a certain place. Deployment is something you deploy. Okay, uh, whether what you deploy determines the type of deployment model. For example, in cloud deployment models, we talk about how the resources or infra is deployed here. Okay, not services, but infra is deployed. We are talking about category of cloud provider, guys. Okay, come out of the services. That is done. This is a concept where how we categorize the cloud players out there in the market. GCP is one player, Azure is one player, AWS is one player, but these guys have something in common. Can somebody say what is the commonality between GCP, Azure, and AWS? Can anybody think of what is the commonality between the three cloud providers? Think about it. Anybody? You can use the resources, guys. They are public cloud providers. Okay, you can. They are not private cloud provider. That means, yeah, providing additional resources, yes, but the real question is to who? To everyone, right side. They provide services to whoever to who pays them. Okay, they don't say that okay, we don't provide services to India, guys, or they won't say that okay, only Amazon or Amazon services will be used in AWS. No, Microsoft doesn't say that only Microsoft employees have to use Azure. No, right? It is open to everyone, right? That is public cloud model, wherein there is certain infra provided by public provided to the public based on the charges and other things, the service and other agreements. Like they will provide certain resources to you in public, to the public at large. Now, what is private cloud? First, we discuss public cloud. Public cloud is scenario wherein the infrastructure is available to the general public at large. Okay, public in the sense it includes industry also, guys. Not barring any industry that okay, this industry can be allowed, this industry can't be allowed, this guy, this person can be allowed. No, it is open to the public. Only criteria is you should be able to be clear to ask what you want. Okay, and you need to be able to you should be able to pay for what you use. So that is the criteria. Okay, then what is private cloud? Okay, private in the sense I have an enterprise. Okay, and only the my organization should use the tools of my organization should be used by my own employees, and the hardware and all will be owned by me. Now there is a subtle difference between private cloud and just a data center. Okay, understand the difference. Okay, not every data center is a private cloud. Remember that. Okay, private cloud should have certain characteristics of the cloud there. What is cloud? I said cloud has certain characteristics. What is that? It should be scalable. Okay, it should have. It should be able to share the resources provide to that. I will give you an example. Okay, in your organization, let's say there is a need for virtual desktop. Okay, like VMs. Okay, now where do you provision the VMs? Provision in the sense create the VMs, virtual machines, and share them and share your data centers underlying hardware and create VMs and give them as service determines it's a private cloud. Or you can create a file share or a storage and share it across your employees or something like that. Or you can have certain inbuilt in-house software, and those software use the computing infrastructure from a single data center, which has which has a capability to serve other softwares also. But it should belong to one enterprise or one entity. Okay, that determines whether it is a private cloud or just a data center or public cloud. So public versus private in it comes. Public cloud is homogeneous. That means the services are uniform across the customers. Okay, can we know which private cloud I am using when using VDI? No, that won't be disclosed basically because of the enterprise reasons. Um, you won't be discussed. But sometimes you can ask your IT team. In private cloud, there are two categories. I'll come to that. In private cloud, there is a way to set up the private cloud. One, you can invest the money, hardware, time, effort, and everything, the company, and they can build their own private cloud. Or there are certain providers. Uh, uh, I don't remember the correct name, but there are certain providers. Even certain public cloud providers also will come set up the data center for you and manage that for you. You pay the rent for that. Okay, but that data center is dedicated to you. I think Tencent or certain companies there are multiple companies which provide dedicated private cloud offerings. Okay, so now to answer your question, Anil, which private cloud I'm using when you are using VDI? No, until the IT team discloses, you might not be able to see that. Okay. So coming to public cloud, the infrastructure is homogeneous, means uniform. If I tomorrow say that a particular VCPU has certain category, like E2 or certain instance, that means tomorrow you also take that E2 category or V2, then that particular amount of storage and thing will not change. It is homogeneous. In private cloud, I can customize the offerings based on the need of the user. Okay, I will have more control over there, and I can tailor make the offerings. Similarly, policy is commonly defined and it is customized. Resource model is shared and multi-tenant. What is the word multi-tenant mean? Multi-tenant means multiple users or multiple applications are sharing a single underlying resource. Okay, it can, so it's a word, right? Very important. Multi-tenancy, multi-tenant. It's a hallmark of public cloud. So whereas private cloud, you won't have multi-tenancy. You will have a dedicated tenant that is your own organization. Then cost model, operational expenditure and capital expenditure. What does the difference? Capital expenditure model means you have to invest your capital or the money upfront for building everything. Operational expenditure means you don't need to build public cloud. Public cloud is already built by Microsoft, Google, and AWS. You just need to pay for the operational expenses you are using. Okay. Then economy model, large economic scale, end-to-end control. That means like if there is huge data center, then obviously Google buys the rack servers at a very cheaper price than if you want to buy your own servers. Okay, economies of scale, volume determines the price, right? So that's how. Then there is another cloud, few more categories. Community cloud. How can I say community cloud is? Let's say um, let's say there are certain universities like Ivy League universities. They want to have a dedicated cloud for their own high performance computing needs. Okay, HPC we call it. Okay, like supercomputers and other things. Then they can have their own community cloud. Or who knows? Like maybe New Delhi government may suddenly come up. You can say that we can have a cloud, community cloud, where only Delhi residents or Hyderabad residents or New York residents can have access to it. So community is rare, and but also it has its own usages. So the final one is hybrid cloud. Hybrid cloud is the new thing in the trend. when you have a mixture of two or more clouds, it can be private or community or public. That means you can link your private cloud with a public cloud, that becomes a hybrid cloud. Or you can link your Microsoft Azure with GCP, that also be called as hybrid cloud. You can link it with enterprise. Then you can ask, if I have one cloud, that is sufficient, right, Vijay? Why do I need multiple cloud? So here comes a very important part called vendor lock-in. So vendor lock-in is a term which became famous after certain cloud providers increased their price after the initial offerings. Okay, what happens? You first introduce a service, and it will be priced at affordable thing, or there is some certain service agreement which are very liberal at the initial stage. Then later on, when the demand increases and most of the customers set up their infra and set up their application, everything, now the vendor slowly changes their policies. Okay, and then what do you what they cannot, they are now locked in, their application is dead. You know how much difficult to set up the entire production grade infrastructure on a public cloud? It takes 10 to 15 engineers to work for 3 to 5 months to set up production level infra. Okay, it's not that easy. Okay, so I have been part of, I'm really fortunate to say that I got the opportunity to migrate, set up, and build, manage, design the infra, and set up the application deployment, everything. So it is not so easy, guys. So vendor lock-in is it have to be avoided. So for that, what companies will do, will have certain features in certain clouds. It also can be that certain cloud is famous for certain aspect. Like Google Cloud is famous for its Kubernetes offering and data offerings. Okay, whereas Azure is famous for its Microsoft 365 related offering. AWS is famous for its compute offerings and other offerings. So you can use cherry pick what you want. Okay, that is one way. So hybrid cloud is composition of two or more clouds, and how you use it, you need to have certain expertise on how to link them. Okay, there are something called VPN gateways, and or you can have a dedicated interconnect to make sure that the link is established. Till here, we are concluding the cloud computing related aspects. We will provide the slides to you, and there are certain theoretical concepts of cloud which for our real day-to-day job purpose, nobody will question. But if you want to understand the theoretical funda behind it, I will share with you the slides, notes. You can go through it. So till here, guys. Any Yes, Nutanix is one service provider. I'm really sorry, guys. Okay. Yeah. Nutanix is one of these several private cloud providers. Thanks, Tarun, for bringing this up. Thank you so much. And any doubts, guys? You can raise your hand if you have doubts. Just let me know. We will take the queries, and then we'll quickly move to GCP. Okay. Let me have a sip of water. Guys, how are you feeling? Like, is okay? My pace is okay. Am I going too fast? Edward, Balaji, Gopi, guys, am I clear in terms of the way I communicate? Am I going too fast or too slow? Do you want something else? Put it in the chat, okay? Yeah, sure. Thanks, Tarun. Thank you so much. So if you have any feedback, like you want something, yeah, please let me know. Thanks, Edward. Thanks for this thing, Anil and everyone. Thanks, Balaji. Thanks, Mohammed and everyone. So, okay, guys, now we have concluded our first part of module one, and we are proceeding to the second part of the module, that is Google Cloud Infrastructure. Now, every cloud provider will have global level infrastructure to be called as a public cloud provider. And most importantly, as I have discussed, there are major players such as Google, Amazon, and Azure, and Oracle, and IBM. These cloud providers will have their setup across the globe to make sure that the clients are offered a similar range of service. I won't say exact, but similar range of services across the globe. Now, I want you to have a deeper look at what I'm showing, and can you quickly tell me what this picture says? Anybody? What does this all these lines and dots? What does it show actually? Can you think of what this is? Mm-hmm. Okay, connections. Okay, Google Cloud Service availability, Google Data Centers. All the answers are correct. Okay. By the way, uh, okay, good. Google Data Centers, Google Cloud Connectivity and Location. Super. Thanks, Santosh. Thanks, Edward. Uh, thanks, Gopal, Sai. Thank you, Anil, Tarun. Good, good, good. Yes, regions. Okay, good, good, Wasim. Anybody else? Yes, guys. So basically, the dots here are the point of presence. Okay, the circles here are called zones. Okay, and the connectivity here is the optical fiber network connectivity. Okay, and these are undersea optical fiber cables. Okay, they lay over it. For reduced latency, they use undersea cables to for minimal disruption and you know maximum performance, low latency purposes. They will have connectivity to all the locations. All of these dots here are points of presence. I will tell what is a point of presence, what is a zone, what is a region, everything. Okay, we will cover them. So now there is a movie. Okay, I cannot recollect the name, but I'll come to that. Why we should have a high speed network and latency? How organizations fight for a millisecond advantage? Okay, for a millisecond advantage, companies fight to set up, invest millions, if not billions of dollars to have one more millisecond advantage over others. How much is millisecond, guys? Okay, it's 1,000th of a second, and we deal with microseconds also. Leave nanoseconds for now. Okay, so now what I want to tell you is how Google Cloud infrastructure is set up, and what are the major areas and what are the major locations available, and how it is spread across. Now whatever you see here, North America, South America, Europe, Asia, Australia, these are called locations, are broader geographies. Okay, when I say North America, it's a continent, right? It's a continent. South America is a continent, Europe is a continent. These are called locations. Now what Google will do, it will select certain location like North America. Now they will set up data centers at one location, or nearby areas, and we call it region. Okay, in North America, if they go in the eastern part, in the eastern US, if they set up data centers, not one, okay, there will be several data centers grouped together in a certain part of that location, then we call it regions. Okay, now for example, East US is a region, Central US is a region, West Europe is a region, South Asia, like our Mumbai, right? South Asia and Hyderabad also is chosen, I think, for one of the Google data center. We already have Microsoft, I think. So these are region where certain data centers are clubbed and set up. Now, zones zones are subset of that region. Okay, now you can be hearing about like US East 1, US East 2, like that. Okay, so there are, each data center is represented by zone. Okay, there are 88 zones and 29 regions across the globe for GCP. So that at global scale, all the users will have access to the cloud across the globe. Yes, I our data centers hardware parts arranged for the cloud. Yes, in each data center, it's Google Cloud's responsibility to set up the necessary hardware necessary virtualization hypervisors running on it, and the physical networking setup for each server to be connected. We call it rack, right? Rack and also there is a co-location, and there are data center related vocabulary. We don't go there, but yes, hardware parts are yes, storage, networking, and compute. They all are provided by Google in a data center. Like what happens now? I have given an example, right? Like let's say in Europe, look, Europe is a location, and in Europe location, Europe West 2 is a region, and in Europe West 2A is a zone, West 2B is a zone, and West 2C is a zone. Now remember, each zone is a data center. Okay, each zone is a data center with its own cooling, power, and power backup, and every infra security and everything. It's an independent one. But when clubbed with these things, right, it becomes a region. Why do we need such a thing? Think about it. Why do we need this elaborate infrastructure? Can't we set up all the data centers? We club them instead of three data centers in three zones. We can take all the infra, put it at one place. Okay, we will take outskirts of London. We'll set up the size of three data centers in one place. We will call it mega data center. Why didn't they do that? Any answer, guys? Data theft, data loss. Yeah, when data theft is the remote possibility, but okay, I to some, yes, yes, data loss, fault tolerance, redundance, latency. Yes, yes, you are bang on, guys. You are right. Yes, whenever something happens, like there is a data center in tsunami. Let's say, what happened after tsunami? The nuclear disaster Fukushima happened, right? A similar disaster happens, an earthquake, let's say in Los Angeles. Let's say tomorrow, God forbid, I'm not saying something will happen, but in an earthquake prone zone or in any natural disaster happens, we don't want to our customers data to be lost. Okay, we don't want any downtime to our applications. So what does cloud provider do? They will they will have zones across the region, and make sure and give the opportunity to us to host our application. If we have a virtual machine running our application, we can have three replicas of our virtual machine with the application on it in three zones. So if by chance, if Europe West 2 has some issue and it goes down, still we have other replicas running. Okay, so that your mission critical application on this virtual machine is always available. That's called resource redundancy. And then what if I have an application running as a SaaS? Hmm? You are not worried about underlying, but what if your application has to be available throughout the globe? I don't want my application to have latency. Okay, guys. Latency means the delay in between the request and the response. Okay, how much gap is there? If there is more delay, that means more latency. Again, tomorrow I will tell you the movie name. Okay, about latency. There is a wonderful movie where the organizations pour in billions to get only 1 millisecond extra advantage. Okay, there are certain scenarios where you need that. One of the best examples is stock market. I don't know how many of you track the this money markets, but financial markets are very sensitive to time. If you get 1 millisecond advantage, you can earn or lose millions of dollars. Okay, I'll give that movie name tomorrow. Okay, so applications are spread across regions, not even zones, to have that redundancy for their applications. Now, let's say it's not only that I will have I will have my application set in regions. There are options where for certain categories you can spread across locations also. For example, I have my cloud storage. I don't want to set it up in one zone, but I can set it up across zones, one in London and one in Belgium. Okay, so uh, so we want to decide how much we can afford to set up that disaster or fault tolerance or disaster resilient setup. We call it DR. Okay. So now, till now, any queries, guys? What is a location? What is a zone? And what is a region? You have the clarity, right? No confusion. No. Now, how does it help you tomorrow when you set up any resource in Google Cloud? You should be aware that, okay, where am I sitting? Where are my organizations clients are sitting? For example, you are working for a e-commerce a startup which is based out of India, for example, okay, or Ola or Uber, something like a carrier model. Now your users are concentrated in India. Similarly, if your users are concentrated in Europe or US, then it is very logical that you want to give them better service at an affordable rate with lower latency, right? It makes a lot of sense to provide or choose the region and zone nearest to your client based on your application and the and provide services so that it will better suit. Now, what are the criteria to choose which region or zones? Which should be the criteria? There are certain decisions to be made. Okay. Now, as an architect, as a designer, or as a principal engineer, I would give highest priority to the type of resources or availability of certain resources as the first priority. That means not all category of resources are available across the regions globally. There are differences, okay, minute differences. But if I want to run my application on a particular capability model or capability resource, then I will choose which is the region providing that. Now that I will skip whether the resources availability is there. Or. The second category is how far or how near it is. What is the latency? The third priority I will give to costing. There is costing differences also. So if you set up a compute engine in Mumbai, the Asia South, versus if I set up a VM in US East, the difference will be there. It will be in cents per hour. Like for example, if I have to pay 50 cents or like certain amount, then there will be like a few more cents you have to pay extra for the locations where demand is relatively low. The demand is relatively low compared to North America as compared to Africa or Asia. The demand is low there. So, or Oceania, for example. So, my criteria or your criteria uh, should be like, how what are the fundamental priority to me or my organization? Is latency a priority to me? Then I will choose the nearest one. If cost and affordability is priority to me, if there is a few milliseconds latency, my users don't bother. Then go for US East or Europe West, which have high demand and more resources. Then cost is also low. Okay, so choose wisely when you set up a resource. Okay, tomorrow you are going to be architect, right? So suggest you need to design things, right? So keep in mind when you design things. And now, what is point of presence? Now, apart from zones and regions, there are smaller data centers, relatively smaller, so that their data is cached and available to the users at a much faster thing. When do we use it? Let's say you have certain you are running Netflix, okay, and in Netflix it's mostly geographical. For example, in India, uh, we have you have several regional languages. Okay, I will take Hindi for example. The amount of users watching Hindi movies, Hindi language movies, or Telugu language movies, or Gujarati movies will be mostly concentrated in India rather than in US. Yes, there are Indians in US or the foreign nationals who might be interested in Hindi movies, but the quantity of users are concentrated more here. So wouldn't it be wise to keep my my movie files or the media files nearer to my users, but that doesn't mean that all my Indian movies will be there in these data centers. No, but I need to find some way to cache the most frequently accessed files in the nearest data center possible, so that whenever users try to access the frequently used one, they will get it quickly. We called caching. Okay, caching or CSHE. Cache is something which is a temporary storage or temporary mechanism whereby you provide the necessary resource which is requested in a much faster pace, but but the only catch is that you won't keep it for permanent. Okay, this will be cached and it will be kept for frequent access and provision of services at a faster pace. Yeah, Hummingbird is a very good movie example. Okay, the hero goes to at length, to provide his own data center, connectivity. Yeah, Hummingbird Project is a nice movie. I'll come up with such examples tomorrow. Okay, so point of presence are used as small data centers across the globe, so that you don't have a region or a zone in Africa, guys, if you have observed or not. But won't Africa or the engineers from Africa doesn't need Google Cloud Services, or there won't be Netflix users, or what? There will be, right? So obviously they need some sort of data center which should serve frequently instead of buffering. If they have to access from US data centers, the latency would be huge. Okay, it might stretch to few hundreds of milliseconds. That is unacceptable. So a human eye can only perceive the difference. Okay, a few milliseconds. Okay, more than that, you will understand the delay. So that is all different thing. Coming back, point of presence are needed to cache the content and deliver the content quickly. We have something called content delivery network. Have you ever heard of something called Cloudflare, Akamai, something like that? They are called content delivery networks. That means I have a site. Okay, give me few more minutes, guys. We are going to wind up the session. It's okay if I take just 5 more minutes to conclude the Google infra overview, and tomorrow we will start with freshly with Google portal and how to access and everything. Okay, guys. Yeah, thank you so much. Thank you. You are awesome. Okay, so CDNs or content delivery networks are designed in such a way that if there is any static data in your website or in your application, like data or like images, media files, which don't need to be necessarily stored in your application servers. Okay, it can be in somewhere which is quickly accessible. Okay, you have a customer interface portal where there is no need to log in at all. It's just a brochure kind of thing. I have a list of items, I need to publish them, and they have to go through the products. They can just browse through it. I don't need to keep that all files in my application server. Yes, when they have to log in and order those, we definitely need that logics to be sitting in our servers. But just to view the browser and see and have a look at our services, they don't need to. They need quick access. Okay, if I have a 1 GB movie, if they with one click they should be instantly start the movie and watching it. They should have low latency. For that purpose, we have something called point of presence, which are smaller data centers spread across the globe. And finally, this forms, okay, this one is fiber optic cable connectivity between point of presence, regions, and data centers. So these are the connectivity. How Google Cloud is making sure that the users across the globe are, provided services. So tomorrow we will start with Google Cloud, and we will give an intro to how the Google portal will be, and how the Google portal works, and what are the different. I'm sorry, guys. Google portal, how the Google resources are organized, what are resources project, and what is the hierarchy, when to use which. These are all we will start tomorrow, and we will also see how to create a free tier account, and in the next week, after tomorrow's session, I expect you to have a free tier account of your own for conducting labs. Okay, whatever I perform here and give you the steps and step by step scenarios, you need to go through them and implement on your own. Only remember, guys, if you want to become a good engineer, you need to do hands-on. Just listening to the classes is only 20 to 30% of it, or not even 30%. In some cases, our human brain is bound to forget some things. So work on with your own hands. For hands-on exercises, I will provide you steps. You need to create your own filter and execute this so that you can remember better and perform better in your organization. So thank you, guys. As I have discussed, we are nearing our free sessions. So quickly join. For those who join, we have certain perks also. We have announced that we will be providing certain services. Whoever trusted us and whoever joins our course will be given these services by Logic Lab Technologies, uh, uh, absolutely free of cost, and these are really invaluable. Who knows, one idea can change life, right? These career building series sessions we are planning in February, these are live sessions, guys. I will be taking them, and our experts will be taking. Each session will be of few hour durations, and we will be covering one aspect of career and how to build it, what are the pitfalls, what are the mistakes, and how you can grow, and these things. Okay, and MongoDB is very important document database. Every company uses it, so make use of this MongoDB series and live end-to-end project. Always remember, companies while they interview look at your holistic knowledge. Not They will not look, okay, this guy is good at computer engine and we will hire him. No, they want end-to-end understanding of the service. Okay, so and GCP a certified engineer earns commands almost double. He can negotiate almost up to 50% more than what he's offered. Okay, so make use of these offerings. Register for this course as soon as possible before the offer expires. Okay, this is Vijay Sharma signing off, and I have provided you the link for this WhatsApp group. Please join and connect with our support team if you have any queries. So when will we have the MongoDB lectures? Okay, I will talk to the support team, Subhanshu. Once we register for the GCP course, we will give access to those videos as soon as possible. Okay, you connect with the team and get the more details from the support team. Okay, Subhash. Anybody else you want any queries? Hope everybody is happy with the lectures. Any feedback, please. Uh, uh, Thank you, everyone. Thank you, Greta, Naga Kalyan, Tirupati, Prasad, everybody. You have dedicatedly, came a disciplined manner. You came, joined the class, attended. I'm okay. So from tomorrow there will be labs. Yeah, the first lab will be tomorrow. Yeah, Anil, correct. The first lab will be tomorrow. But don't worry. You can execute those labs at your convenience. I will provide you the steps and the necessary steps for that. Okay. Okay. Free demo class will stop from the fifth session. That is like from tomorrow. After that, like maybe Monday would be the last session, or just connect with the support team. They would guide you. Okay. Sai, you can connect with the support team. But make sure, guys, for the effort we are putting in, right? For the bonuses and for the effort and the value we are adding to your lives, think about it to extend your knowledge and other things. These things will help. And also GCP as a course by itself has a huge demand outside. You know how difficult it is to fetch a good Google Cloud resource out there in the market. It's very difficult, to find a resource who has hands-on expertise on Google Cloud. Just search for Google Cloud openings there, and you will understand. Okay, guys, we have exceeded our time by 10 minutes. I'm thankful to you for giving me permission to spend 10 more minutes to complete our course. Tomorrow's agenda I have discussed. We will start with the Google portal. How many ways we have to access Google portal? We will demonstrate some things, and we will have one of the labs tomorrow. and also we'll show how to create a free tier account. And once you create a free tier account, on weekends you will do that lab on your own, and come up on Monday with the feedback. Okay. Thank you guys. Thank you so much. Bye. Have a nice day. Bye bye. Thank you.